Hey everyone, and welcome to today's Explainer. We are exploring one of the absolute most fascinating frontiers in tech right now, natural language processing, or NLP for short. Basically, our goal today is to understand exactly how we bridge that massive communication gap between humans and machines. It's this wild journey from messy, totally unpredictable human speech over to the precise mathematical world of computers. And honestly, unpacking how it all works is just an incredible process.
Okay, let's dive right into this. Think about something most of us literally do every single day. Imagine just asking your phone, hey, what's the weather like today? Within seconds, it completely understands your words, it figures out exactly what you want, grabs the right info, and talks back to you in totally natural language. It feels like magic, but what you're actually seeing is natural language processing hard at work.
So here's our roadmap for the Explainer today. First up, what is NLP? Then we'll look at the ambiguity of human language, followed by how machines actually process that language. After that, we'll hit the transformer revolution, and finally wrap things up with some real-world applications and challenges. All right, part one, what is NLP? Let's get the basics down. So NLP is essentially the ultimate intersection of AI, machine learning, linguistics, and computer science. It's the hidden engine powering everything from ChatGPT to Google Translate. But to really grasp why it's so incredibly tough to build, we kind of have to look at how humans communicate. Take a look at this sentence. I saw a man with a telescope. Okay, mini mystery time. Who actually has the telescope? Is it you looking through it at the man? Or does the man you're looking at just happen to be holding a telescope? As humans, we resolve this instantly using context. But computers, they have zero inherent context. They have to learn it all through some seriously complex algorithms.
Moving to part two, the ambiguity of human language, our ultimate antagonist.
You see, in the story of NLP, human language itself is incredibly complex. It's the villain here. It is packed with double meanings, hidden context, and all these messy, unspoken rules that machines absolutely hate. This ambiguity is exactly why NLP is one of the hardest fields in all of AI. And this brilliantly illustrates the problem right here, lexical ambiguity. Think about the word bank. On one hand, it's a place where you keep your money. On the other hand, it's the side of a river. So if I tell a computer I went to the bank, which one did I go to? Without any surrounding context, the machine is completely blind.
Oh, but it gets even trickier. We also run into syntactic ambiguity. Take the phrase, flying planes can be dangerous, right? Does that mean the act of piloting the plane is dangerous, or that planes currently flying in the sky are dangerous? And then we have semantic ambiguity. Look at this one. The chicken is ready to eat. Is the chicken sitting at the table wearing a bib ready for its dinner? Or is the cooked chicken ready for us to eat? We humans instinctively know the difference, but machines, they get totally lost.
Which brings us to section 3, how machines process language. Let's see how we solve this ambiguity. So how do we actually fix this? Well, this is where we pivot to our protagonists, the NLP algorithms. To conquer all these wild ambiguities, researchers have seriously evolved their mathematical toolkits over the decades. It's been a crazy progression. Back in the 1960s up to the 80s, we relied on first-generation rule-based systems. Basically, people manually wrote out if-then grammar rules. Like, if the sentence contains hello, then reply hi. Super simple, but totally impossible to scale up. Then the 1990s brought us statistical NLP. Researchers started using probability to just guess the most likely next word, using models like n-grams. Skip ahead to the 2010s, and we hit the deep learning era, where neural networks automatically learned language patterns for things like translation. And finally, 2018 triggered the transformer era, which was honestly the biggest revolution in NLP yet. But look, regardless of the era we're talking about, how does a machine actually digest a sentence? Think of it a bit like playing with Legos. If you hand the machine the sentence, "I love studying artificial intelligence," the very first thing it does is tokenization. It breaks the text down into digestible building blocks, or tokens, like I, love, and studying. Next, it strips out the stop words, those really common words like the or is that don't add much meaning. From there, it uses specific techniques to break words down to their roots, tags their grammatical roles, and scans the whole thing for important entities.
Let's zoom in on a few of those steps to see how they transform the data. Take stemming. Here, the machine aggressively chops words down to their root studs just to reduce the total vocabulary size. So running simply becomes run. Lemmatization, on the other hand, is a bit more intelligent. It preserves the actual dictionary meaning, so a word like better is smartly normalized to good. And then there's named entity recognition, which hunts for important subjects. It sees a word like SpaceX and instantly tags it as an organization, or sees Elon Musk and tags it as a person. This, by the way, is exactly how search engines pull out crucial info so quickly.
Now, what's really interesting about this slide is how we translate all those processed words into something a computer can actually calculate. Because remember, computers understand numbers, not words. So we use something called word embeddings to convert these words into vectors. Words with similar meanings get similar numerical vectors. And it creates this amazing mathematical relationship where the vector for king minus man plus woman approximately equals the vector for queen. I mean, how cool is that? It proves visually that machines can successfully capture abstract semantic concepts using pure geometry and math.
All right, Section 4, the Transformer Revolution. Time for a totally new architecture. That mathematical foundation we just talked about paved the way for a massive shift. In 2018, the game completely changed. A brand new architecture dropped that forever altered how machines read and comprehend context at a massive scale. This breakthrough came from a now famous paper called Attention is All You Need, which introduced the attention mechanism. Just like you and I focus on the most important words when we're listening to a story, this technique lets AI models dynamically focus on the most relevant words in a sentence. It actually mirrors human context comprehension, letting computers process entire sentences simultaneously instead of just reading them strictly left to right.
Let's look at another example to see how this builds our solution to that pesky ambiguity. Read this sentence. The animal didn't cross the road because it was tired. Now, how does a computer know what it refers to? Is the road tired or is the animal tired? Well, thanks to a process called self-attention, every single word looks at every other word simultaneously. The model focuses its attention to grasp the context, correctly linking it back to animal. And this breakthrough is what allows us to train efficiently on massive data sets, resulting in those huge billion-parameter models you've heard of, like GPT, Claude, Gemini, and Llama.
And finally, Section 5, Applications and Challenges. Let's bring this back down to the real world.
We've seen the mathematical theory and the crazy scale of these transformer models. But what does this massive processing power actually do for us today? Well, the real-world triumphs of NLP are literally everywhere. It powers machine translation, letting tools like Google Translate seamlessly flip English into Urdu. It drives sentiment analysis, instantly figuring out if the emotion in a product review is positive or negative. It's the brain behind your customer support chatbots, the text summarization tools that shrink down long articles, the speech recognition that makes Siri work, and information retrieval, which is how search engines understand complex queries like best AI courses near me, instead of just matching exact, rigid keywords.
However, we have to keep it balanced. Despite all this major progress, there are definitely ongoing challenges. Machines still struggle a lot with subtle human context and nuanced meanings. And because these models learn from basically the entire internet, they can very easily inherit and replicate our own human biases. Large language models are also infamous for hallucinations, where they confidently just make up completely false information. And finally, multilingual complexity is still a massive hurdle. Languages around the world vary so much, and adapting NLP perfectly across diverse languages like English, Urdu, Chinese, and Arabic is a really unique, difficult challenge for researchers. So, to pull it all together, the core takeaway is captured perfectly in this quote from our source material. NLP is the science of teaching machines to understand, interpret, and generate human language, and it is one of the foundational technologies behind the AI revolution. I mean, think about how far we've come. We've journeyed all the way from those basic, manual, rule-based systems to transformer-powered AI that captures complex semantic meaning through pure math. Every AI assistant, translator, and search engine relies on this science. It absolutely is one of the foundational pillars of the entire AI revolution. And as these language models continue to aggressively improve, we are rapidly moving closer to a future where human-machine interaction is as natural as chatting with a buddy. Which leaves us with a really fascinating question to ponder. As NLP evolves, will communicating with a machine soon feel completely indistinguishable from talking to a friend? Thank you so much for joining me for this explainer. I really hope this deep dive into natural language processing has sparked your curiosity about the incredible technology powering our everyday lives.